so prove that the two angles opposite the equal sides of an isosceles triangle are equal. All right, so we're trying to prove these two angles are equal here in this isosceles triangle. So, I need a triangle to look at. So what we're going to do first is draw a triangle. I've labelled mine ABC. And so I would say in triangle ABC, so I'm setting it up in triangle ABC. And I'm going to let the vector AB be vector U and the vector BC. So it depends on how you set it up, and it doesn't have to be the same as this. Be V, and it's an isosceles triangle. So I'm also letting the length of that vector U be equal to the length of that vector V, because it's an isosceles triangle. All right, so what do we know then? We also know the vector AC, so if I make it from A to C, it would be vector U plus V there. So I also know that. Alright, so I could say, therefore vector AC is made up of, so it's always nice to use the big letters and then substitute the little ones, the little vectors in. So it's the same as AB plus B to C, which is U plus V. Okay, so let's get down to business. We're interested in the angles. So if we're interested in the angles, we're going to use our formula. So remember on your, we know it, but so U dot V is cos, cos theta. Actually, I don't know how it's written on your, is it written like that? Can't remember. Anyway, you can look it up. So if I want cos theta to be the subject, because I want the angle to be the subject, I could rearrange it to look like that if it doesn't already look like that. All right, so that's what I'm going to use. So if I first look at cos of this angle here, so BAC, so let's look at cos of angle BAC. We've got U dot U plus V if we use this formula. So we've got the vectors surrounding it. So U dot, and they're both heading out. Both got arrows out. So U dot V on the length of vector U and the length of vector U plus V. Alright, so let's have a look at simplifying that a bit. So if I do this, I've got U dot U plus U dot V on those lengths. And we know that that's just, so U dot U is the mod U squared. So don't forget that. That's our handy one to use. Alright, so this is what we've got so far. And there we go. Alright, so we've simplified it. Let's see what we get for the other angle. So now we're looking at cos of BCA, and I'll just write this out so I have room. Still using that formula though. So cos of angle BCA. So in this case, think of BCA, I could extend it like this, oops, and vertically opposite angles are equal. So we can still think of the angles, the vectors going outwards, and we're finding this angle between those two vectors. All right, so what vectors do we have? We've got vector V dotted with U plus V on mod V and mod U plus V. So the lengths of those two vectors. So here we go. So again, we've got U dot V or V dot U, doesn't matter. And we've got V dot V on those lengths. And that is the same as U dot V plus. So we know that's the same as vector V modulus all squared. All right. So remember what we're trying to show, that these are the same, and we can say, well, as long as we know that, so these are exactly the same, if our mod U squared, or our length of vector U all squared, equals our length of vector V all squared, then they're going to be the same, and we know that they are the same. So we can say, oh, okay, so cos of BAC does equal cos of angle BCA, since we know we knew we were given this, or we set it up already. And you could also say, therefore, if you want, that the squared has to equal the squared as well. All right, and then, you know, therefore, if the cos of the angles are the same, therefore the angles in this case are the same because they're the angles of a triangle. And therefore the two angles opposite the equal sides of an isosceles triangle are equal. So remember, go back to what you're trying to prove and just do your mini sentence based on that.